Hey everyone, ready to go deep on those James Webb discoveries? I mean, it's like we just got a new pair of glasses for the universe. We can see further and clearer than ever before. And we've got research articles, scientific papers, all sorts of stuff. And honestly, some of it's pretty mind-blowing.
Yeah, you know what's really cool? How the James Webb Telescope, or JWST for short, it uses infrared light to see through all that dust and gas. It was basically blocking the Hubble telescope. Like Hubble was trying to read through fog, but the JWST just puts on its night vision goggles and boom, everything's crystal clear.
Okay, I'm hooked already. So we're not just talking prettier pictures then, right? What kind of game-changing discoveries are we seeing with this infrared vision?
Let's start with the early universe. Before JWST, we thought the first galaxies formed like 500 million years after the Big Bang. That was the timeline we were pretty sure. But hold on tight, because JWST found galaxies way older. We're talking just 200 million years after the Big Bang.
Whoa, so the universe was throwing galaxy parties way earlier than we thought. That must be causing some chaos for astrophysicists.
Totally. Like, imagine you're expecting a tiny village and you find a huge city. These early galaxies are so much more developed than our models predicted. With structures so complex, it's making us rethink how quickly they could have formed.
So does this mean we're rewriting the Big Bang timeline? What does this mean for, well, everything?
It's not so much about rewriting the timeline, but more refining how we understand what happened back then in the early universe. It's super hard to observe. But JWST is giving us our first clear look, and the data is forcing us to rethink our assumptions about galaxy formation and evolution.
It's like we had a blurry map of the early universe, and JWST gave us a high-res satellite image. I bet it's not just pretty pictures, though, right? What specifically are scientists learning from these early galaxies?
One of the big things is the rate of star formation in the early universe. JWST is seeing galaxies just bursting with young stars, way more than we expected. It's like the universe had a super intense baby boom in its early years. It suggests that star formation back then was much faster and more intense than it is now.
Whoa, a cosmic baby boom. That's wild. But what was triggering this rapid star formation? Was it different from how stars form today?
That's the million-dollar question, isn't it? Some theories suggest that the early universe just had the perfect conditions for making stars. Denser gas clouds, higher radiation levels. It was like a star-making factory.
Okay, so we're seeing how JWST is changing our view of the early universe. That's amazing.
Yeah.
But what about those incredible images of exoplanet atmospheres? That's something I was really looking forward to diving into.
Oh, yeah. That's where JWST's infrared vision really shines. It can analyze the light passing through an exoplanet's atmosphere, and it can actually identify different molecules. And we're not just talking about detecting them. JWST can figure out how much there is, the temperature, even how it's spread out in the atmosphere.
That's incredible. It's like reading a weather report from a planet light years away. I remember reading about the detection of water vapor on a planet called K218b. That seemed like a pretty big deal.
It is. Definitely. K218b orbits its star in the habitable zone, which means it could have liquid water on its surface. Now, just because there's water vapor doesn't mean it's a water world, but it's a huge clue.
So we're not saying there are aliens swimming around on K218b.
Yeah.
But we're saying it's worth taking a closer look.
Exactly. JWST is giving us the tools to move beyond just finding exoplanets. Now we can start to figure out if they could actually support life.
Okay, so we've covered the early universe and exoplanet atmospheres. That's a lot. But what about dark matter? I know it's this huge mystery, and I'm curious how JWST is helping us understand it.
Well, dark matter is, by definition, invisible. We can't see it directly. But we know it's there because of its gravity, how it affects things we can see. And JWST is so sensitive that it can actually see how dark matter's gravity distorts light from faraway galaxies. It's called gravitational lensing.
So even though we can't see dark matter, JWST can see its shadow, basically, by how it bends light.
Exactly. And by studying these distortions, scientists can map out where dark matter is in the universe. And that helps us understand how it shaped the formation of galaxies and galaxy clusters.
That's fascinating, using a cosmic magnifying glass to study something we can't even see. So what have we learned so far about dark matter's distribution? Is it spread out evenly, or are there clumps of it?
That's one of the big questions JWST is helping us answer. And what we're finding is that dark matter isn't uniform. It's not just spread out evenly. It actually forms these massive structures throughout the universe, like a giant cosmic web with galaxies and galaxy clusters forming along its filaments.
A cosmic web of dark matter. That's a pretty wild image. But why does dark matter clump together like that? And how does it influence the formation of visible matter, like galaxies?
Those are some of the big mysteries surrounding dark matter. One of the leading theories is that it's made up of these things called WIMPs, weakly interacting massive particles. They only interact with each other and normal matter through gravity and the weak force. And this weak interaction could explain why dark matter forms these large-scale structures. Its gravity pulls in normal matter, and that's how galaxies are born.
So it's like dark matter is the scaffolding that the universe is built on.
That's a fantastic analogy. We can't see the scaffolding directly, but we can see its effect on the structure. And JWST is giving us the tools to study this scaffolding in incredible detail.
I'm already starting to see how JWST is revolutionizing our understanding of the universe. We've covered so much already, from the earliest galaxies to exoplanet atmospheres and the mysteries of dark matter.
And we've only just scratched the surface. JWST's mission is far from over, and there are countless more discoveries waiting to be made.
So JWST is amazing for seeing the early universe, but what about closer to home, our own solar system? Can it show us anything new about the planets and moons right here?
Oh, you'd be surprised. JWST is great at looking far away. But it can also study our own cosmic backyard. Like, it's been taking amazing pictures of Jupiter. We're seeing details in its clouds and auroras that we never saw before.
So like getting a fresh perspective on an old friend.
Exactly. And it's not just about the pictures. JWST's infrared vision can actually study the chemicals in planetary atmospheres, map their temperatures, and even look beneath the surface of icy moons.
Oh, speaking of icy moons, I read about how JWST might help us find life on places like Europa and Enceladus. They have those oceans under the ice, right? Is JWST strong enough to see through all that ice?
Not directly through the ice, no. But it can see the plumes of water vapor that erupt from their surfaces. Those plumes are like little windows into the oceans below. They carry chemical signatures that could tell us if there's life down there.
Whoa, so we could find alien life without even landing a probe. That's incredible. What kind of chemicals would scientists be looking for?
They'd be looking for specific combinations of molecules called biosignatures. They're like indicators of biological activity. You know, the stuff life needs, like water, oxygen, methane, carbon dioxide, things like that.
Right, the building blocks of life as we know it.
Exactly. Now, finding those molecules by themselves doesn't mean we found aliens. They can be made by geological processes, too, not just life. But finding them together in specific combinations, that's when it gets interesting, especially if they're out of balance with the planet's environment.
So it's like finding a recipe book, but in an alien language. One word doesn't tell you much, but a whole sentence gives you a clue what they're cooking. What would be a really exciting recipe to find in an atmosphere?
One example would be oxygen and methane together. On Earth, those gases react quickly with each other, so if they're both there in large amounts, it means something's constantly making more. And on our planet, that something is life.
So finding that combo on another planet would be a big hint that something's alive over there.
It would definitely be a reason to investigate further. But of course, we have to be careful about jumping to conclusions. There could be processes we don't know about that could make the same thing happen without life. That's why scientists look for other clues too, like complex organic molecules, or even changes in the planet's light that might suggest there's vegetation.
Okay, so it's a whole investigation, not just one thing. But is looking at exoplanet atmospheres the only way JWST is helping us find aliens?
Not at all. Remember those icy moons, Europa and Enceladus? They have those huge oceans under the ice, and some scientists think there could be life down there. JWST can study the water vapor plumes that erupt from those moons and look for those biosignatures, those hints of life.
Yeah, we're getting a sneak peek into alien oceans without even drilling through the ice.
Exactly. It shows how versatile JWST is. It's not just for looking at distant galaxies, it's for exploring our own solar system, too, and for tackling some of the biggest questions about life in the universe.
Okay, so we've talked about how JWST is like a time machine. We can see back to the early universe, but can it also see things that are closer to us in time, but still incredibly far away?
Absolutely. One area where JWST is making a big difference is in studying star formation. It can look into those dense clouds of gas and dust where stars are born. We can actually see the process of a star igniting, how it all begins.
So like the cosmic nursery is where stars are born. I remember seeing Hubble images of those, but I bet JWST gives us an even better view.
You're right, JWST can see through all that dust and gas and show us details that Hubble couldn't. We see those star-forming regions in amazing detail. The jets of materials shooting out from young stars, the disks of gas and dust that form planets.
It's like watching a cosmic ballet, with stars and planets being born right before our eyes. But how does studying star formation in other galaxies help us understand our own solar system?
Well, by seeing star formation in different environments, we learn about the different ways planetary systems can form. We see how the mass of a star, what the gas cloud is made of, all sorts of things, how those factors influence the types of planets that are born.
So like comparing different recipes for making planetary systems, seeing which ingredients lead to different outcomes, and maybe even get clues about how our own solar system formed.
Exactly. That's one of the big goals of using JWST to study star formation. We're trying to piece together the whole story of how planetary systems form and how our own solar system fits into that bigger picture.
Wow, it's incredible that we can see these processes happening billions of light years away.
Yeah.
But what about the other end of a star's life? Can JWST tell us anything about how stars die?
That's another area where JWST is making a huge contribution. We can see the spectacular death throes of stars, from the slow fading of red giants to the explosive supernovae.
I remember those supernova images from Hubble, but I'm guessing JWST gives us a much better look.
What are scientists learning from these observations? One of the big things is how the universe gets enriched with different elements. When stars die, they release heavy elements that were created in their cores. These elements then spread out into space, into those giant clouds of gas and dust, and that provides the material for the next generation of stars and planets.
So it's like a cosmic recycling program. The death of stars creates the building blocks for new stars and planets, including our own.
Exactly. And JWST lets us study this cycle in amazing detail. We can see the different elements produced in different types of supernovae and how they spread throughout galaxies.
That's incredible. It's like getting a glimpse into the cosmic alchemists that created the elements that make up our bodies and everything around us. But what about black holes? I know JWST is helping us understand those mysterious objects too.
Black holes are really hard to see directly because their gravity is so strong it traps light, but JWST can see the effects of black holes on the things around them. For example, we can study the disks of material swirling around black holes that get superheated and emit tons of radiation.
So like a cosmic whirlpool around a drain that we can't actually see.
That's a great way to put it. And by studying those disks, we can learn about the black hole itself, its mass, how fast it's spinning, things like that.
What about those jets of material shooting out of black holes? I remember seeing pictures from other telescopes. Can JWST see those too?
Oh yeah, JWST can see those jets in incredible detail. They're like beams of high-energy particles launched from the poles of the black hole, and they can stretch for millions of light years.
Millions of light years. That's insane. What are they made of, and what makes them shoot out like that?
They're made of super hot, energized particles, like electrons, protons, even heavier ions. The exact way they're launched is still a bit of a mystery, but we think it has to do with the powerful magnetic fields around black holes.
Like a cosmic particle accelerator. So what happens when these jets hit the stuff around the black hole in the galaxy?
They can have a huge impact. The jets can heat up and ionize nearby gas clouds, which stops them from cooling and forming new stars. But they can also create shock waves that compress gas clouds, which could actually trigger new star formation in other places.
So black holes are both creators and destroyers.
Yeah.
They can stop stars from forming in some places, but start them in others. That's a pretty complex role to play in a galaxy's evolution.
Absolutely. And JWST is giving us the tools to study this back and forth between black holes and galaxies in more detail than ever before.
This is all so fascinating. We've covered so much, from the early universe to the deaths of stars, black holes, and even our own solar system. It's like JWST is more than just a telescope. It's a window into the entire history of the universe.
Couldn't said it better myself. It's giving us a whole new perspective on everything, from the tiniest planets to the largest structures.
And we're just starting to explore all the data it's gathering. I can't wait to see what other discoveries come out of this incredible telescope. All right, so we've seen how JWST is shaking up our understanding of the early universe, giving us a peek at those far-off exoplanet atmospheres and even helping us figure out black holes. But there's one question that always comes up when we talk about space. Are we alone out there? Can JWST help us answer that?
That's the big one, isn't it? The question everyone wants to know. And while JWST can't directly tell us if there's other life out there, it is giving us new tools to search for signs of life in ways we couldn't before.
So it's not going to spot little green aliens waving at us, but maybe it can give us some clues, point us in the right direction.
Exactly. Remember how we were talking about JWST analyzing those exoplanet atmospheres? Well, scientists can study what those atmospheres are made of and look for things called biosignatures.
Biosignatures, right, like chemical fingerprints that might mean there's life. What kind of things are we talking about?
Think about what life needs, at least life as we know it. Things like water, oxygen, methane, carbon dioxide, the essentials.
The building blocks of life.
Right. Now, finding those molecules on their own, that doesn't necessarily mean we found aliens, because they can also come from geological processes, not just life. But finding them in specific combinations, especially if they're not in balance with the planet's environment, that's when it gets really interesting.
So it's like finding a recipe book, but it's written in some alien language. One word doesn't tell you much, but a whole sentence gives you a clue what they're cooking up. What would be a really exciting recipe to find in an atmosphere?
A great example would be finding oxygen and methane together. Here on Earth, those gases react with each other really quickly. So if you find a lot of both, it means something's constantly making more. And on Earth, that something is life.
Ah, so if we found that combo on another planet, that'd be a pretty good hint that something's alive over there.
It would definitely be a reason to take a closer look. But we always have to be careful about jumping to conclusions, right? There could be processes we haven't discovered yet that could do the same thing without life. So scientists look for other clues too, like complex organic molecules, or even changes in the planet's light that could suggest there's plants or something.
So it's like a detective case. We need more than one clue. But are exoplanet atmospheres the only way JWST is helping us in the search for life?
Nope, not at all. Remember those icy moons we talked about, Europa and Enceladus? They have those huge oceans under their icy shells. And some scientists think there could be life down there. Well, JWST can study those plumes of water vapor that erupt from the moons and analyze them for those biosignatures, those hints of life.
So we're basically tasting those alien oceans without having to drill through miles of ice.
Exactly. It just shows how amazingly versatile this telescope is. It's not just for looking at faraway galaxies, it's also for exploring our own solar system and for trying to answer some of the biggest questions about life in the universe.
It's clear that JWST is changing the game for astronomy. But what about beyond science? Has it affected pop culture at all, or how people see science in general?
I think it's safe to say that JWST has really captured the public's imagination, maybe like no other scientific instrument has before. Those incredible images, the groundbreaking discoveries, it sparked this new excitement about space. You see it everywhere. News headlines, social media, even art and literature.
Yeah, it's like it's given everyone a dose of cosmic perspective. Our everyday problems seem a little smaller when you're looking at galaxies billions of years old.
Exactly. And I think that's a really good thing. Science, especially astronomy, can connect us to something bigger than ourselves. It reminds us that we're part of something vast and amazing. And in a world that can feel so divided and chaotic sometimes, that connection can be really powerful.
You know, what really strikes me is how much we still don't know about the universe. It's kind of humbling, isn't it? With every new discovery, we uncover even more mysteries.
Absolutely. That's the beauty of science. It's not about having all the answers. It's about the constant search for knowledge, the joy of discovering something new, realizing that the universe is more complex and amazing than we thought. That's what makes it so exciting.
So as we wrap up this deep dive into JWST, what's the one thing you want our listeners to take away from this conversation?
I hope they walk away with a sense of wonder and curiosity, a desire to learn more about the universe and our place in it. And I hope they realize that JWST is just the beginning. It's a stepping stone to even more incredible discoveries in the future. Who knows what we'll find out there?
Well said. And for everyone listening, if you want to learn more, there are tons of resources online. NASA's website, scientific journals, even popular science magazines. And don't forget your local library or planetarium.
Exactly. There's a whole universe of knowledge out there waiting to be explored. So keep looking up, keep asking questions, and never stop exploring.
This has been an incredible journey through the cosmos, and we want to thank you for joining us. On this deep dive into the James Webb Space Telescope discoveries, it's clear that JWST is more than just a scientific instrument. It's a symbol of human ingenuity, our desire to learn, and our fascination with the universe.
Until next time, keep exploring.